Hello, welcome back to Problem Solving with Miss Jones. Today we're going to try a projectile motion problem. So after reading the problem, I've sketched it, everything that's given to us, and I've written out what the question's asking for. The max height, the total time, and the final velocity. There's no rule that says which order you gotta solve these things in, so I'm just going to go ahead and get started. First thing I want to do is break up this velocity into x and y components. Vx and velocity initial in the y. So because Vx is the adjacent side, Vx will equal 100 cosine 25, and Vy will equal 100 sine 25. So when you do that math, you get 90.6 and 42.3. So the next thing I want to do is I'm going to go for the height first. So I'm going to say this is my initial here, and the final will be the maximum height. And then I'll want to make an x, y chart to get down all the information we have about those 2 points. So the x velocity is 90.6. We don't know the x distance. We do know in the x direction that there is no acceleration. And that's it. In the y direction, the initial velocity is 42.3. We know the acceleration is negative 9.8. And so what I'm going to do here is just, since I want the total height, I'm just going to pretend this here is the ground, and I'm just going to solve for this distance and then add it to 20 to get the total height. The cool thing about this max height spot here too is that the final velocity in the y direction there is 0. So I've got 3 things. That's enough stuff in order to solve for y. So now it's time to pick an equation that magically just popped up here. So when you look at these, we have velocity initial, acceleration, velocity final, and distance. What's missing from that list is time. So I'll pick this equation here because it's also missing time. So when you substitute and solve there, I substitute in all the variables, and I solve for x, and I got 91.3, so that the maximum height is 111.3 meters. All right, so now moving on to the last 2 things. We want the total time for the trip and the final velocity. So I'm going to change my initial and final. So now the initial is going to be the same, and the final is going to be here. So because of that, I'm going to make a whole new chart in a different color. So we have x and y. And I'm just going to start filling in what we know. So the y velocity is the same, 42.3, and the acceleration is negative 9.8. We don't know the final velocity now, but we're going to want to find it eventually. That's the second thing. And, oh, we know the distance. It's going to be negative 20 meters. So from here to here, it goes down 20 meters. I don't care that it went up, but it goes down 20, so that's negative 20. And then we're going to want to solve for time also. So actually, we don't even have to do anything with the x direction. We're just going to solve for time. So let's ignore the velocity final. I'll pick the equation that doesn't have a velocity final in it. Use these 3 pieces of information to solve for time. You know what? I changed my mind about that because I noticed that if I use that, I'm going to have to solve a quadratic, which you're totally allowed to do, but I don't want to. So instead, I'm going to solve for velocity final first, using this equation that doesn't have time. And then once I have velocity final, I can use the nice easy equation up here to solve for time. So let's do it that way. So when we substitute into that equation and solve for velocity final, I get 46.7. Just remember that was a square root, and it's going to be traveling downward, so technically that's a negative 46.7. All right, so let's go back up to the diagram here. The final velocity is not just that, because it has a y and an x component. Fortunately, we already know what that x component is. We solved for it back in the beginning. So let me draw another little triangle down here. We know that the y component is 46.7, and the x component is the same as it was in the beginning because there's no acceleration in the x direction. So that's 90.6. And then we can just solve for the hypotenuse there, doing a squared plus b squared equals c squared. When you do that, you get 101.9 meters per second. That's the final velocity. Let's see, let's box our answers here. All right, so one last step to solve for time, and I'm running out of room on this paper. I'm going to do it right over here in this space. Now that we have the final velocity, negative 46.7 in the y direction, we can go ahead and solve for time using this top equation here. So negative 46.7 equals 42.3 plus negative 9.8 times time. All right, when you solve that, I got t equals 9.08 seconds. All right, so like I said earlier, we could have solved for that first using the quadratic, but if you see those tips and tricks, then go ahead and take them. So there you go. That's how you solve a projectile motion problem. Hope that was helpful.